How to Test This, the podcast designed to help software testers understand risk and adopt new testing solutions with ease and confidence. Your host is Mahamadou, a quality assurance consultant with over 10 years of experience across multiple industries. In each episode, he'll talk to different experts and learn from them about how they test.
Hello, everyone. Today, I'm happy to welcome Callum Akehurst-Ryan. For those who don't know him, Callum is a principal test engineer, quality coach, and keynote speaker. He has over 80 years of experience across multiple industries and methodologies. He wrote articles on exploratory testing, continuous testing, diversity in engineering. He believes that testing is a craft that never stops evolving. Teams should be learning, questioning, and exploring all the time. He is a strong advocate for exploratory testing, working alongside with developers and designers to uncover quality issues. And he is also advocate for testers taking ownership, being proactive, pushing insight to the team, and not waiting to be asked. So welcome, Callum. It's a pleasure to have you.
Hi, nice to be here.
You're welcome. So in this episode, we'll be mainly talking about how to test continuously. We'll start with your journey on how you become community lead. After that, we're going to talk about what it means to test continuously and why it's important for team nowadays. After that, we're going to talk about common problems we see in software testing. And then we're going to conclude with good practices on how to implement continuous testing effectively and conclude with advice to level up as a tester in 2026. So without further ado, let's get started. So you've been tester for over 80 years. Can you tell us about your journey on how you get into testing and how you decided to make a living out of it?
Yeah, so my journey, I think, is very similar to a lot of people. I didn't know about software testing. I was working in the customer services department for a financial organization, and I actually started working there on the same day as somebody who was a software tester, a quality analyst. And so I got to know her, and she was awesome. We used to go to lunch together. And I think it was some years into working at the financial company, and she reached out and said, "Hey, we've got apprentices, we've got apprenticeship roles in like quality and software testing. Would you like to go for it?" And I did, which was really cool. So I started off my testing journey in financial services as an apprentice. Starting off with, and this was a long time ago, but we were using manual testing, lots of scripted testing because it's in finance. So it was a regulated industry. So we had to capture all of our test evidence. First of all, it was on things like Excel, but then moving on, we had all the different tools. I think Quality Center was one of the first ones. I don't know if that's even used anymore. And over time, like new tools in automation started to come along. So there were a lot of record and playback tools. We went through all of that. And yeah, I developed my skills for many years in finance. So learning how to come up with tests, test architecture, working about environments, and then from there built out. It wasn't until I left finance that I started learning about agile testing. I think very early days, we were talking about the ideas of exploratory testing, trying to come up with like, what does it mean you don't have an expected result? So I was working in broadcasting at that time. So I was trying to teach other people who were very engineer focused and mechanical about exploratory testing. So trying to do that chaos engineering mindset of things, going, oh, well, it should do this and this, but what happens if this? What happens if that? And I spent a long time across a number of different industries working in that exploratory space, working to teach people agile testing, working as an agile coach and as an agile team lead in a lot of spaces as well across cross-disciplinary teams. I remember the first team sort of, and again, I was working in public safety at this point, the first teams that were cross-disciplinary coming together. So working with developers, being the only tester in the team, having to work really quickly to come up with tests and explore what was going on with what was being developed at the time, and working really closely. My first pairing with developers happened then. And again, that just built up my skills working in that automation space as well, until I started to become quite proficient at leading and coming up with strategies and working within startups and small engineering organizations, as a consultant and like as a first embedded tester, to go, hey, look, here are different ways we can test. And that wasn't even working with testers at this point. This was just working with engineering teams, and helping them to come up with ways of working. And then really recently, I've been working as a quality engineer and a quality coach. So literally being the only tester in the whole company, not just the one team, in the whole company, the only tester, going, hey, teams, you need to test. Here's how we can test. Here's how you can test. I shouldn't do all your testing because I'm one person. You should be doing a lot of testing, and here's how we can do it. And that's meant having to learn a lot of things, right? Pipelines, unit tests, through to acceptance tests, all the different non-functional things, but also working on like software development life cycles, working on product roadmaps and what they look like, helping teams to think about what does good look like? What do you want your product to be? How good do you want it to be? And now a new skill, AI. How do we develop in an AI world? How do we use testing agents into those agentic development models? So it's been a real journey, and there's lots of little bits in there, but a real journey of starting off in that finance world as a manual tester, confirmatory scripts, to all the way now where now I'm sort of coming up with and strategizing and advocating for people, going, there's a lot of uncertainty. How do we uncover information about this uncertainty? So yeah, big journey.
Yeah, amazing journey, very impressive. But with everything going on, like, how did you become such an active contributor with blogging, social media posts, involvement with Minister of Testing? What problem did you see to say, okay, I want to contribute more to the community?
Yeah, I was suggested to do it by an old boss of mine. I used to work with a guy called Dan Ashby, who's you've probably seen some of his models out there. He's got a big figure of 8 model about continuous testing that lots of people use. And he was a very big blogger and speaker, specifically in the Ministry of Testing back then. And he recommended it to me, because as a tester, you need to put ideas out there, you need to develop your influencing skills, you need to be able to talk to different people. And the more publicly you can do that, the better your skills become, because having conversations about quality is the best ways to effectively learn about quality and learn how to talk about quality. So I actually started off with creating a blog way back. I think I might have hidden them. I had some really bad blog posts originally that were like a couple of sentences long, but I started in that space, just coming up with ideas about blogging. I went to my first ever test bash from Ministry of Testing, and yeah, from there I did a 99-second talk. I built some more blogs off the back of what I'd seen there. I'd done some sketchnoting and I shared those. And when you get involved in the community, when you start talking, you start to see that lots of people really want more information, like what you're doing here. You're sharing information, making it available to people, and helping them to understand different aspects of quality. So I spent a long time like just explaining the basics and teaching the basics. So thinking about exploratory testing, what is it? Why do we do it? How do we do it? Talking about API level testing, like what is that? How do we do it? And it came from a place of just trying to help other testers understand things. And nowadays I'm still talking. I'm all over LinkedIn, and I'm still blogging, talking about like new concepts. I talk a lot about quality engineering. What does that mean based on the context that I have working with engineer teams? And what does AI testing look like? What prompts can we use and share? And it all comes from a place of just sharing that information and trying to help other people navigate quality and navigate testing.
Yeah, I definitely agree. You have a very good resources for people to look for when they are lost, and we all been there, I'm sure. And over the years, what's the most common misconception you heard about software testing?
Ooh, that's a good question. Um, some of the biggest misconceptions that I've seen, not only within the community, but like within engineering practices as well, is the idea of testers not being technical or testers not being able to solve wider quality problems from we end up with engineering teams and developers seeing the materials that are put out there and thinking, oh, testers only really know how to do one thing. And a lot of testers themselves will think, oh, I'm not technical. I only really need to do one thing. And they push back a lot. So the misconception sort of builds up, hey, you know, we can only basically do the basics of testing. We can look at functional testing, we can do the ticking things off when we know something, or that we're gatekeepers for testing, that we're not inquisitive, and that we're not working with engineering teams to see what really matters there. A secondary and related, real big misconception about the testing community and testers is, that we break things and that we don't build things, and that we're not here to help engineering teams. It puts this like dev versus test. We just find bugs. We just like breaking things. Lots of people in quality are there trying to help build the right thing, trying to help engage, teams in going, what does good look like? How do we build the right thing? Like, have you thought about these additional quality dimensions? So, yeah, another big misconception, as well as that not being able to help engineering teams, is that misconception of we just break things. And a lot of us don't just break things. You think in any testing that you've done, you've passed a lot of things, probably more things than you failed things, right? Lots of your tests are successful. You prove that things are good. So testers are not there breaking things, they're proving that things are good. It's not just a breaking mindset, it's a, trying to help build things mindset as well. And we're building frameworks and we're building ideas and we're building strategies. So yeah, a big misconception there of just that
Yeah,
conflict.
yeah, it's true. And that way you can build confidence so you don't have the users being the first testers finding problems. Totally agree with this.
Yeah, definitely. And that's what we're here to help with is that sort of shaping of how do we shorten feedback loops? How do we make it so that the right information has been found as early as possible so that we can make meaningful decisions on things? It's not about gatekeeping. It's about going, hey, here's some information. How do we all make a decision on, was this good enough? Would we put this in front of a user? Is it okay that a user tests this sometimes? Yeah, definitely.
Yeah. So okay, now we talk about you. Let's talk about the continuous testing approach. In simple terms, can you define what that is, what it means, and why it's important?
So continuous testing is effectively a core belief in modern development practices. So a lot of us now subscribe to agile ways of working. And that agile way of working basically means trying to get things from inception, the idea, through to into a customer's hands as quickly as possible. And this has been really embraced by engineering communities because, like, you might know that we now have pipelines, we have a lot of automation, and code is pushed mechanically and delivered into environments automatically tested. Excuse me. So we're at a place now where we have optimized for speed of delivery from a small idea of something through all the way to getting it in front of a customer because we want, or most organizations and teams want to provide customer value as quickly as possible. Continuous testing is the idea of running tests throughout that life cycle. we used to have the idea of a testing phase. And in some organizations and in some contexts, we still have that testing phase. We go to the idea of going, idea, build it, test it, ship it. And that test it part is the real place where it really gets tested. And a lot of us are familiar with that. In continuous testing, we break out of that phase of testing and we spread testing throughout everywhere in the life cycle and learn from that. So idea, tested. Building something, test it. Testing phase, still test it. Deployment, test it. Post deployment, test it and feed back into new ideas. You might see a lot of these figure of 8 diagrams or circle diagrams that basically showcase this. And it just basically says during every phase of coming up with something, putting it together, releasing it and putting it in front of a customer, we test throughout. And that's basically what continuous testing is. It's just testing everywhere.
And what is the benefits compared to before to implement this continuous testing?
Yeah. So when we are doing agile development and when we're doing modern development, we want to get things through to customers as quickly as possible because we want to put value in front of customers. And all of our engineering practices are basically set up to quickly go from here's an idea, build it, develop it, and ship it. And that's going to get faster now that we have AI. Continuous testing allows us to help with the velocity and the speed at which we build and ship things because we basically test earlier, we test frequently, it shortens the feedback loops, it can stop us building bugs in earlier. So if we're shifting left, so if we're testing earlier, testing in the idea phase, we're basically going, hey, there might be some tricks here, there might be some problems here. We could stop bugs from happening. We could stop building the wrong thing. We can stop having to define everything out in a lot of detail because we can test ideas and, flesh things out through our tests. Whilst we're building things at the code level, whilst we're in our test phase, which might be more of an acceptance testing sort of idea, we can do a lot of testing, but targeted and smaller testing that builds up a whole picture of things so that, again, we can have confidence in what we're shipping. It can be faster. And then when we've deployed something and put it in front of a customer, we can test from our customer to learn what they like, what's working, what's not working safely, because that allows us to have to do less testing earlier and gets things out there faster. So the main points of continuous testing is just to speed up, but speed up with safety. Because everyone wants to go faster, and there's always a discussion, speed versus quality. No, continuous testing lets you have both. You can have speed and quality, but that quality is good enough. And then understanding that you can learn from your customers, or you can learn in a later stage or in an earlier stage of your development.
Yeah. So traditionally in a waterfall, we are just waiting for the build to be ready to test. So does that mean we have to be more proactive and take ownership and be vocal about what we can do?
Yeah, a lot of that can be even just educating people or working with people in those earlier phases as well. It's really worth noting that for some people and in some contexts and some organizations, you're not set up to do these things, right? There's a lot of people who will say, I'm not given a seat in ideation or requirements analysis or, defining requirements. And that's very fair. Sometimes like you can't take ownership of pushing yourself into things. But what we can do is try to show value, try to show that testing can happen in these earlier stages. So rather than waiting for a build, we could be looking at requirements and saying, hey, requirements are happening. Here are some risks. Here are some problems that you might face in those. Here are some ways that it might go wrong. Show the value, and then maybe teams will go, hey, bring in the tester. They're thinking whilst they're writing requirements because they can spot things. Or maybe rather than waiting for a build, just waiting there. We can be going to our engineering teams and saying, hey, do you want me to look at, the unit testing or the code testing that you're doing here? How are you building these things? Do you want some support in this? Now, this requires actually starting to talk to engineers. It requires actually having to have a bit more of a breadth of knowledge about different areas of engineering. But again, it can help because as testers, we know a lot of what should be tested, what makes for good levels of testing, right? So we can work with engineers to help them with that. Even if we can't read the code, even if we can't write unit tests, we can say, hey, talk me through your tests. Help me understand, there might be some risks here. What have you built? There might be some risks here. So again, it's building that earlier, shortening the feedback loop, making it so you don't have to deploy it into a staging environment and then test it there because it's already been covered off earlier. So yeah, that's a lot of what we do in this continuous testing, not waiting, not saying I just test in this little box, but trying to spread. And in order to do that, you just need to have a lot more influence and a lot of a breadth of understanding of what quality can be.
Exactly. And does it include also testing in production?
Yes. So whatever organization you're in, whoever you are testing in production. So for example, no company has ever dragged me in, Callum Akehurst-Ryan, to say, hey, Callum, we want to exhaustively test everything before it hits production. Therefore, we want to know your opinions on our product. Do you like it? How are you going to use it? Right? No one does that. No one's gone and dragged you into their company to look at their staging environment, right? The first time that they get any insights as to whether you, as a customer, as an individual, like something is when it's tested in production. Now, lots of times we're not going to raise bugs on anything, right? But you have an opinion. Yeah, you'll have an opinion on these sorts of things, right? So that's what I find is every single company is testing quite a lot of stuff, whether it be at a specific customer level, at a specific customer opinion level, there in production. And just to give a more mechanical or more technical result to that, right? If you think a 100 character long field, free text field, right, with Roman characters, say, just that's it. That's our field. There are more combinations that can exist in that field than there have been seconds in the universe. So, yeah. So, free text fields, you cannot have exhaustively tested it because if every test would have to take such a fraction of a second in order to have automated it, in order to have tested it, right? So, by that logic, you're always having to test fields in production. Inputs, the variations of inputs are always tested in production. You can minimize that, but you are testing in production. And that's good. That's important because it's pragmatic. You can't do billions upon billions of tests of everything, right? So you go, some things just have to be tested in production. What is it safe to test in production? What do we not worry about testing in production? And we always talk about users being really important. And the user's the only one that can decide what quality is. Users matter, right? Their opinions, therefore, are what we test in production. So it's part of continuous testing. We should always be looking at what's in production, what are users thinking about it, how are they using it, are there any problems coming from that? We don't just deploy something and then that's done, never look at it again. We should be going, right, what are the opinions on this? Do people like it? Are they using it in a weird way? Are they changing how they use it? And something we should remember is that because quality is something is good at a time for a person, right? Well, tastes change over time. So you always have to be testing in production once you've released something. If you've never looked at changing tastes or changing user behaviors or what they want, things would never change. We'd all be on the same version of Windows as Windows 95. We'd all, be using the first generation of Mac products. Nothing would look different. Nothing would be different. So, yeah, that's why this idea of testing in production is so important.
Yeah, and that's perfect transition because that brings a specific problem we see in testing. Like, how do you communicate the fact like we are taking a risk-based approach, but at the same time we cannot test if billions of test cases on. There's always a risk, and it's never enough. Like, how do you communicate that?
And this is something that I think the testing community finds really difficult, right? Testers come from a place of gatekeeping, right? They want to say, I have decided that this is good based on my testing because it makes you feel important, it makes you feel powerful, and that's how a lot of us are taught how to test in the first place, right? What we're really bad at doing is going, what's good enough? What does good enough look like for my product? Like what would people accept? Like it doesn't have to be perfect. It doesn't have to be the gold standard. What will people accept for this in this product? Right? And there are some things that are non-negotiable. Like it should have to work. Errors should be handled fine for the most cases, right? Or it should be accessible, or it should work on a mobile phone and a app, desktop. So we can start to look at those non-negotiables and say, these are the things that we should really test for. But then when you start digging into that, we start to go, where's good enough? And that's what risk-based testing is mostly about. It's about going, where can we pull down to so that we can ship something? And good enough doesn't necessarily mean we have to live with it as well, right? So what's good enough can be, well, if it goes wrong, can we fix it quickly? That could be good enough to not know that something's broken because we can fix it in 5 minutes. Fine. Or we can revert it. Fine. Get the users to test that stuff. Or what stuff that we'll probably fix later so it doesn't really matter. Fine. We'll be pragmatic in that space. So what does good enough look like that? What are things we just don't care about? Do we not care about specific aspects of usability, for example? Will we sacrifice that for complexity and simplicity, or learnability? Will we sacrifice that in order to get out to the market? Because a lot of times in testing, we always go gold standard. We always go, everything has to be perfect before we will let it get released, right? And you don't have to do that. You don't have to reach 100% coverage. And let me ask you, have you ever been told your bar for quality is too high by your team? Oh, you haven't? Oh, okay. So myself, I've been told this by engineers. They go, oh, your bar for quality is too high. And what that means is you're testing stuff that teams don't care about. So I'll ask you another question. Have you ever raised bugs or defects that never get fixed? They just sit there
Yes,
in a backlog. Yeah? Yeah.
Yeah, of
Again,
course, all the times.
yeah. So this means that you're testing, you haven't tested to good enough, you've tested to too much, right? If you're never going to fix something, then it didn't matter if you found that information out because it's never going to get fixed. And sometimes as testers, we get to a place of going, oh, but the more bugs I find, the more value I'm bringing to the team. Well, not if they're never going to fix them. It's just noise. It's just nothing. We need to find things that matter to the team. So that's when good enough really is important. So that then we can focus on the right testing, fix it at the right time, maybe get opinions and maybe get things from our users. Yeah.
Yeah, take care. I really like this idea of good enough. I mean, even in this podcast, I expect everything to be perfect, but good enough, it's good enough. It keeps you moving
Exactly.
forward.
Yeah.
Yeah.
And that's really important now is to go, engineering teams have optimized their processes to deliver things faster. So you need to be able to really work within the idea of good enough and pragmatism to support them doing that. Because no company wants to go slower. No company. Like, this is why testing times get squashed all the time. Companies don't want to deliver slower. They want to get stuff out to customers. They want to get things out there. And that means working with good enough to help drive that, and being influential and going, right, we have said good enough means this, which means I need the time to test to this. Not like up here somewhere, but to good enough.
Exactly. Yeah, another problem we can see in software testing is our reputation, unfortunately. Many people look down on this job. What is it? What is this for, according to you? Is it because of the lack of clarity, consistency, standards in terms of how we call us? What's your opinion on this one?
So the idea of testers being looked down on is coming from a place of not understanding or not seeing the value that testers are bringing to the development pipeline, the software engineering lifecycle. I actually did a talk called "You're Not Ready for Quality Engineering" at a conference called PeersCon earlier this year, where I went out and I spoke to engineers, engineering teams, heads of engineering, CTOs, all the important people, basically our customers as testers. And I said, what do you want out of testers? What is it that you want? And if we can look at like what that value is, what value do quality advocates bring into teams, we can start to be seen as value add. We can start to be seen as people that are needed in teams and not looked down upon. So when we looked at like what is it that engineering teams want? Well, first and foremost, they want people that help build things with them. They don't want test versus dev. They don't want to be in conflict. They don't want the memes. And I'm sure you've all seen the memes on LinkedIn, the ones that sort of go like, it doesn't work on my machine. Oh, well, it does work on my machine. Well, we're not shipping your machine. These conflict things. They want people that will work with them, not against them, right? So, and not just people who are going to throw bugs at them. The bugs that, like the backlog that we talked about a minute ago, no one's going to fix that because no one cares. We're building something together. We know what that thing is. We're not just trying to break it in every way. We're trying to go, no, this is good enough. This is something that we're building. But engineers and engineering teams also want technical specialists who understand a lot about quality. They want to be able to solve quality problems, right? So engineering teams will go, how do we test quickly in a pipeline? So we as quality advocates and specialists need to go, cool, okay, here are your options. You can test early, you can test your specs, you can test your requirements, and here's how you can do that. Here's what unit testing looks like. Here are frameworks that you can use. Here's when to use a unit test versus an acceptance test. Here's when to pragmatically use manual testing and exploratory testing to do things and why we use it. And here's when to get customers to test things and we test in production. So they want people that can help solve those problems, but also going, cool, let me help you solve security, accessibility, usability testing, scalability and performance testing. These are all things that are going to be really important with the advent of AI as well. So they want people that can solve those. They want coaches, people who help teach engineers how to test. So that they're not looking at us because we're teaching them, right? But how often have you seen, oh, devs can't learn how to test, they have a build and we have a break mindset? We're not helping ourselves there, right? So we're gatekeeping that information. They want people who can, and they want testers to basically be able to teach them things. So that means having consistent terminology. That means helping them to understand things. That means not shooting down ideas or not gatekeeping terminology as well. So I've said manual testing quite a few times already. I think we all know what manual testing means, and engineers know what manual testing is. But online, people go, there's no such thing as manual testing. It's just testing. That doesn't help people understand types of testing, right? We're gatekeeping. So that makes people start to look down on us a little bit because they're not getting the value that they want. So if you're more interested, I've written some blog posts and I've done some talks on the specifics of these things. But generally, like the problem space in the industry is to say engineering teams aren't seeing the value that testers can bring, and testers aren't really advocating for the things that engineering teams care about. Testing fast, delivering fast, being pragmatic, working to good enough, solving lots of quality problems, working with people. A lot of the stuff that we put out there, and if you look at LinkedIn today, I'm sure you'll find a lot of them just go, agile testing is dead. No, it's not. Manual testing is dead. No, it's not. AI, no one should use. Oh, but you can use it. Oh, but you should never use it. Test versus dev, fight, fight, fight. It doesn't make us look good. So we need to just be a bit better advocating for the right things and the things that effectively our customers care about.
100%. 100% agree. Um, another things I've noticed, another problem is, in one hand, as you said, we talk a lot about AI, which is non-deterministic. And in the other hand, we see like the industry shifting toward SDET, where it's more perceived as checking. Do you think it's a good evolution for testers?
I think what we're actually seeing that shift towards is quality engineering rather than SDETs in a lot of organizations. And quality engineers being those sorts of people who can, as I said in the previous answer, very much solve for a lot of problems within testing, solve for a lot of quality discussions and knowing what to cover. When we talk about AI being non-deterministic, well, the results of AI or the specific code generated by AI might change, might be more like ephemeral, like code is going to change a lot. But there are things that are still deterministic and that we do care about checking effectively. And that is things like behavior. You don't want your customers to keep having different workflows, right? You want those to stay the same. So those tests need to stay the same. You can automate those, get an SDET in, lovely, lovely. What else matters? Well, security vulnerabilities, patterns of vulnerabilities, patterns of behavior still matter and still can be somewhat deterministic with tooling and is somewhat experimental as well. Sorry, somewhat exploratory as well. So there's a bit of both needed there. So there are still areas in that space. Data testing, right? We don't want any of our AI or agents looking at data, corrupting data, changing data. There was a company, I think it was called Sassy, that basically allowed agents to touch their database. It flushed their database entirely and their company died overnight because there was no backups. The AI basically, killed it dead. So data and data protection and making sure that data between deployments stays the same is really important. So again, another deterministic test that we can check for. So these are the behaviors, the high level stuff, like the what of our product. What does it do? Like, what is its data? What is its security? That matters. The how, that's all changing because that's non-deterministic code. That's changing, it's mutable. Another thing that we can check again is following rules, following patterns that are somewhat deterministic. How accessible is your front-end code? How maintainable and scalable is your front-end code? How performant is your front-end code? Some of this is a little bit exploratory, but it is still deterministic, and we can test those things. So in the world of AI, when we're looking at that, and we worry a lot about this non-deterministic thing, it's the code itself, how the code is written, that becomes somewhat non-deterministic. But we can use deterministic tests to ensure products stay consistent. And that's when, you need strong skills in automation, tool usage, lots of SDET stuff that's happening there. A lot of the exploratory work that we've seen is, again, going to be very tools focused and is going to be talking to the types of quality attributes that I mentioned there, like how accessible is this? How supportive is this? Trying to use exploratory testing for edge cases is going to be really difficult because that's going to be changing a lot. So we need to look at what we can fix down rather than what's going to be changing a lot. I've also tested AIs and testing for non-determinism as well. And the ways you do that is just pattern matching. You have to look at patterns. And so don't try to lock things down with deterministic tests. Be really exploratory in your testing. Look at patterns that continue existing. So for example, if you were testing like a city, let's look at a city, right? And you were trying to model a city and you modeled a power outage in your city and you had people in your city, look at your hospitals. After a power outage, do more people die? Does that match the data of what happens in real power outages? So look at data, look at what exists there and try and match them one to the other, because that then helps you to navigate non-deterministic behavior. Just like look at patterns rather than specifics.
Thank you. So great value here. So now let's talk about how to implement continuous testing in practice. Like let's say I'm in a project and I don't have any build ready. How can I start implementing this methodology? Like what can I ask to test and how do I get started?
Yeah. Well, first and foremost, the first thing to do is to understand like what is your environment? What is your project environment? What can you push for? What are people open to doing as well, right? If you come into an organization, if you work within an organization that's quite traditional, that doesn't want to, implement continuous testing, it's going to be very difficult for you. It's going to be very frustrating. All you can do in those sorts of situations is start trying to build influence, start advocating, and start sharing information. So a lot of what I do is I try to share information about testing that's going to support people with the pain points that they have now. So I talk to people a lot. But let's say that you have buy-in, right? You've got a team that's really excited. They want you to help them. What can you do? Well, what we want to be doing, ideally, is breaking out of that silo, breaking out of that phase of testing, right? So we talked about our waterfall model. We talked about going, right, I'm just waiting for stuff to happen. What can I do? We can break out of that and we can talk about shift left, which is testing earlier. So if you think of a timeline, anything left of testing is earlier, or shift right, which is after testing or later than that testing phase. So right on the timeline. So in order to shift left, what we can be doing is we want to think of ways to test requirements. There's lots of practical ways that we can do that. We can be looking at requirements and doing risks analysis on them. So have a look at them, come up with risks, capture those, share them with people to say, hey, when you come to building this, think of these things. Think of the risks around this. That's what a lot of like early exploratory testing looks like. Or you can get involved in, we call them, the term is three amigos sessions. There are other names that are non-gendered. You can call them triforce, you can call them power of three, you can call them three hats or story shaping. What they effectively are is a session where somebody who's going to build something, so an implementer, the business, somebody who wants something, and somebody with a quality mindset come together to look at requirements and go, cool, you've asked for this. Have you thought about this? So it's basically trying to think of risks, helping shape those requirements early. We can do even more things shifting left. You could think of things like, what does good look like? Sit down with your company, sit down with your product and go, what does a good product look like? So I don't know if you've ever done this, but have you ever been told by your company like how performant, how secure, how accessible, how good your product needs to be? No.
Never.
So how can you test for quality if you don't know how good it should be, right? So
good question.
And it's really true. And lots of companies are really bad at just framing what makes a good product. What do we as a company care about in terms of our product? So it's worth sitting down and going, cool, what does marketable look like? What does well branded look like? What does performant, scalable, like how maintainable does this need to be? What SLAs are there for maintainability? You know, observability, like how well do we want to learn from our customers? So have those conversations, start shaping what does good look like as a product. So that's another thing that we could be doing early. Then whilst things are being built, we can work with engineers, we can talk to them, we can say, hey, what does your test coverage look like in terms of units, integrations, branch statement coverage, acceptance testing? How do we get these tests into a pipeline? So there's a lot we can be doing there by working with engineers. Even if you were to look at designs, like look at architecture, look at the UX designs, but also the system designs and say, hey, are there risks here? What could these risks look like? You've got APIs here. Where would they fail? You know, you've got microservices. Would the data transformations fail? So there's a lot that we can do there by helping people just understand risks. And you don't have to like be able to code. You just have to be able to start understanding problems in terms of like what a system looks like. And then raising risks, asking questions is quite big there. And then putting those pipelines in is really important because we want everything to be in a pipeline. So helping people get tests into a delivery pipeline is really important. So that's a lot of different ways that you can start shifting your testing earlier, but then we've got testing later. And that's a problem that's really hard for people to understand. And lots of engineering teams are really bad at testing in production, right? So thinking about what would we test in production? How would we test in production? What's safe to test in production? So there might be stuff like user testing. There might be stuff like tools that we do for tracking user usage, or error handling, error logging, monitoring, health checks. Lots of those sorts of things are really important as well. We might want to look at net promoter scores, interviewing people, or even looking at like reviews that people have put online for stuff. We can test for that. We can do A to B testing, and that's where you basically go, cool, we're going to put two different options of a workflow out and see what gets better results. Try for that. So there's lots of different ways that you can test in production. And a lot of that comes from asking, hey, what can we learn about? What do we want to learn about? And how can we start advocating and pushing for adding that tooling in?
How do you see the role of testers evolve over the few years coming up?
More testers will be in the space of quality engineering and being quality advocates, helping organizations to understand what the guardrails are around agentic and AI-based testing. If you're not already involved in AI testing, I think you will be as time develops. And you'll be helping codify a lot of the knowledge that we have as testers into AI-based software delivery lifecycles to say, when is it appropriate to test? What is it appropriate to test? And how good does this need to be? So we'll be focused a lot less on execution and more on the strategy of testing, which means knowing a lot more about testing and what looks good in that space.
Okay, last two questions to conclude. Like, the market for QA or tester is not easy nowadays. What advice do you have for people struggling or looking to enter in this market?
Show your value, know what your value is, and understand value in terms of what is it that the people who are hiring you want to see. All of the engineering managers, all of the hiring managers want you to be able to show that you can work with AI, that you can work with pipelines, that you're pragmatic, and you can help teams deliver fast but safely. So show people practical ways that you are able to achieve that. So put use cases out there, share stuff out there that says, hey, I have helped teams to do this thing that helped them ship fast with confidence.
Okay, got it. Is there anything I did not ask you about you want to answer or let people know?
Yeah. If you're interested in learning more about quality engineering or like just reaching out and speaking, you can find me on LinkedIn. you can find me on my website. And yeah, please do like drill into any topics and come and talk to me about them, because I'm always keen to see what people, what questions people have and how we can teach people in testing.
Yeah, thank you very much. So that's been a valuable conversation. Thank you for your time or your insight. I really appreciate that. I wish this episode would be 2 hours, but that's all good. I think, yeah, as you said, I will share resources for people to reach out to you directly. You have a blog full of blog posts on talks as well. So it's akehurst-ryan.com. Is it correct?
Yep, that's
Okay,
right.
and also your LinkedIn profile so people can reach out to you. So that concludes today's episode. I hope you found it valuable. If you did, please share it with your colleagues and stay tuned for upcoming episodes. I'll continue to learn from experts and ask them about how they test. So this is Mamadou, and that was How to Test This. Thank you very much, and see you next time.